Hi and Assalamualaikum. So for this video, I will be talking about solubility product constant, common ion effect, and predicting precipitation. Okay, first we look at what is actually solubility and solubility product constant. So we have an example here. I will be using sodium fluoride, NaF. Okay, let's look at the first equation there. Sodium fluoride dissociate into sodium ion and fluoride ion. Sodium fluoride is the salt here. Dissociate into ion Na plus and also F minus. The ratio is 1, 1, and 1. Okay, so that is for sodium fluoride. As we know, because of the ratio is 1 to 1 and 1, so we can write down the KSP. KSP equals to Na plus and F minus. Okay, so for example, if given to you the solubility or the molar concentration of NaF, so what do you need to do? For example, it is given to you 1 molar of NaF. 1 molar of NaF. So if I have 1 molar of NaF, how many molar? What is the molar for? What is the concentration for sodium ion and fluoride ion? So it will also be 1 molar also, because the ratio is 1, 1, 1. So if you have the concentration of sodium ion and fluoride ion, you can simply put it in the KSP expression. So if it is 1 molar, 1 molar, 1 molar, you can place it in, and it will be, you can calculate the KSP value. Okay, so the value is depend on the dissociation. So that is if given solubility or molar concentration, and then you can calculate the KSP. But if given the KSP value, how do you want to calculate the solubility if given to you the KSP value? So you need to use the ice table. So if sodium fluoride dissociate in water, so you will use this ice table here. So NaF is solid, it will not be considered in the KSP value. So you have initial concentration for sodium will be 0 for both sodium ion and fluoride ion. It is 0. Changes is plus X and plus X. This is because it is 1 molar each, equivalent to the salt. Next, you have equilibrium X and X. So that then you need to put it in the KSP value here. So Na plus is X, F minus is also X. So you will get this KSP equals to X square, and then you square root KSP, you will get the solubility of X. So X is actually Na plus equals to F minus equals to NaF. So if you get the X value, you already solve what is the solubility of NaF in water. Okay, we look at common ion effect. So what actually is common ion effect? That is, common ion is actually an pre-existing ion in the solution. For example, here we will use an ionic solution 0.5 molar Na plus. So what does it mean by that is the concentration, the ionic solution already have 0.5 molar of sodium ion. So if we look at Le Chatelier, this is the normal dissociation of NaF into sodium ion and fluoride ion. But if NaF, sodium fluoride, we dissolve it in 0.5 molar Na plus ionic solution. What does it mean there? The sodium ion, the concentration already increased as much as 0.5. Initially, it is 0 here if in water, but if you dissolve in ionic solution 0.5 molar Na plus, sodium ion will increase in concentration. So based on Le Chatelier, if this concentration increase, what will happen? Yes, sodium ion excess will react with fluoride ion to produce more NaF, the solid. So you can deduce that the solubility of the salt decrease if you try to dissolve it in an ionic solution because of the common ion. Okay, so we look at here, what are the difference between these two ice table is the initial for sodium. This is 0, this is 0.5. Okay, so we focus on the second ice table here. So x because the ratio is 1 to 1, and then 0.5 plus x and x. Because of x is very small, the value, so we will assume 0.5 plus x equals to 0.5. And then you will have this KSP. KSP equals to 0.5 times x, and then you need to solve x. So now x still the same. X is the concentration for sodium, but this time you will expect the value to be little, to be smaller compared to this one because of the common ion effect. Okay, now we will go to the second one. Okay, so for the second equation, I would like to use this example, calcium nitrate. So calcium nitrate will dissociate into calcium ion and nitrate ion. The ratio is 1:1:2. So to write down the KSP expression, KSP equal to calcium and also NO3 minus to the power of 2 because of the ratio here is 2. Okay, so this is the KSP value of the calcium nitrate. So if we want to calculate what is the KSP if the concentration is 1 molar. So if this is 1 molar, calcium will be 1 molar, nitrate will be 2 molar. So you just plug it in 1 and 2 here, and then forget 2 to the power of 2 will be 4 times 1, so you will get the KSP value. That is depend on the dissociation. So that is how you get the KSP value if given the molar concentration or the solubility of calcium nitrate. Next is, if you want to calculate using the ice table, is to find out what is the solubility if given the KSP. So you need to use the ice table. It is 0 initially. Change is x and plus 2x. This is because the ratio is 2 to x, x to x. And then just plug it in the KSP value here. Calcium is x, nitrate is 2x. To the power of 2, you get 4x cubed. And then to solve x, you will need to do this. KSP over 4, and then you square root this value here, and then you will get x. X is actually calcium nitrate, and because of the ratio is 1 to 1, so you can assume that the x value is the solubility of the salt itself. So that is for the first part. Okay, so for example, we want to mix this salt with the salt from our previous example. Now we have two salt, sodium fluoride and calcium nitrate. So if we mix both of these in this soluble salt, we will get one insoluble salt. It will be calcium fluoride. Calcium fluoride. So we need to determine whether calcium fluoride will be precipitate or not. So to get that information, you need to find out what is the amount of concentration of fluoride and calcium respectively. So before we look at the calculation, we look at calcium fluoride first here. So this is the answer later on, but we look at these two important information that you need to have. Calcium fluoride dissociate into calcium ion and 2F minus. And then to write down the KSP or QSP, it is calcium fluoride to the power of 2. These two information you need to calculate. Okay, KSP will be given to you, then you need to compare QSP and KSP. So now we will like to calculate these two concentration before we proceed. This is the final answer later. Okay. So let's look at the first one, calcium fluoride. So if we have 0.2 liter of 0.06 molar of sodium fluoride, so what is the amount of mole of fluoride? So based on the ratio, 1 mole, 1 mole, 1 mole, 1 mole of sodium fluoride will produce 1 mole of fluoride ion. So you need to search the mole for sodium fluoride. So 0.06 times with 0.2 liter, you will get 0.012 mole for sodium fluoride, which also equal to fluoride ion. So this is the amount of fluoride ion that will be given or will be present in the mixture. Okay, 0.012 mole. You cannot use this mole yet because this is not the concentration. So you need to find the concentration. You need to remember that if you mix these two salts, both of them have their own volume. This is 0.2 liter, this is 0.1 liter. So now the concentration for fluoride must be divided with the total volume, 0.3 liter. So 0.012 mole over 0.3 liter, you will get the value 0.04 molar. So you can put this directly into the QSP. QSP fluoride ion is 0.04. Okay. Now we calculate for calcium. So for calcium, if we have 0.1 liter of 0.3 molar calcium nitrate, what is the number of mole of calcium that you will have? It is 0.03. How do I get that? Because the ratio for calcium nitrate and calcium is 1:1. So it is easier. You can just 0.3 molar times with 0.1 liter, you get 0.03 molar for calcium nitrate, which also it is the same with calcium. So you get 0.03 mole. Okay, 0.03 mole. Next, you need to calculate the concentration for calcium. So 0.03 mole divided with the total volume just now, 0.3 liter, you will get 0.1 molar. And then directly put it in the QSP expression, 0.1, 0.04 to the power of 2, you calculate it. This is the final answer that you will get, 1.6 times 10 to the power of -4. And then if you compare QSP with KSP, so you can deduce that QSP is larger than KSP. What does it mean by that? Is if QSP is larger than KSP, means that the dissociated ion is high. That's why the value of Q is higher than KSP. So if the dissociated ion is high, if calcium and fluoride ion is high in concentration, based on Le Chatelier, it will favor reverse reaction. So if it is favoring reverse reaction, what will be produced? Calcium fluoride solid. The precipitate will be produced. Okay. So if QSP is smaller than KSP, what does it mean by that? If QSP is smaller than KSP, you can deduce that the dissociated ion is little. The concentration is very little. So based on Le Chatelier, if the dissociated ion is low in concentration, calcium fluoride, the solid, will dissociate more. So no precipitate will be produced because it will favor the ions. Okay, so that's all for this video. I hope that you can understand this chapter. This will be the last video for LU5. So thank you. Have a pleasant end of semester and good luck for your exam. Thank you.